busy. I'm going to start writing on the board. Oh man, you're going to hate it.
Oh God.
And I'm going to need multiple colors. Alrighty. And then if I remember, I'll tell you about Osceola. Okay. This is catabolism. It's the catabolism part of metabolism. And this is covered in chapter 5. Is it chapter 5? Yeah. I always get my chapters mixed up because every time we switch books, I'm like, somebody's got a really nice lunch. A warm lunch. Who's got warm lunch? Somebody's eating warm lunch. I smell it. Sounds good. Not like you bitter. Okay. 2 types of cellular respiration. Your textbook author does not call fermentation cellular respiration, but I do. But it won't be confusing on your test. Don't worry, I didn't make a question that would be confusing on the test. All right, let's do the first type. Aerobic. Oh no, let's do anaerobic first. It's easier. Oh no, I don't know. Which one do you want to do first?
Anaerobic.
The hard one first?
Do the hard one first.
Okay.
The hard one first? Aerobic cellular respiration. Your total ATP yield is 38 per molecule of glucose. If you're bacteria. $36 for eukaryotes due to mitochondria. Mitochondria, let's call it entrance fee. Okay, I'm already running out of board space. All right, let's see if we can pull this off. Step number 1 is glycolysis. Glycolysis, splitting my glucose in half. I wrote your chemical formulas long ways, but this time I'm going to go sideways because the board is sideways. So don't let that freak you out. In glycolysis, you start with a 6-carbon sugar, which happens to be glucose. 1, 2, 3, 4, 5, 6. So this is glucose. Oops. A 6-carbon sugar. Colton's like, I'm staying home today. I don't blame him. Glucose. In glycolysis, the whole purpose of glycolysis is to split your glucose in half, right here, at this middle bond. And your end result is going to be 2 pyruvates. So that's carbon to carbon to carbon plus carbon to carbon to carbon. That's 2 pyruvates. Okay? When I broke this bond in the middle, my red pen is starting to die. When I broke this bond in the middle, electrons are released, and little hydrogens, remember, that are poking off, they follow. So I'm going to put an arrow that shows electrons are released. That's electrons with an S. So just in case you're not clear. So the little E stands for electron with a negative sign. That's an electron. And I'm going to put a little S because it's more than one. And what else is released? Hydrogens. A little H with a plus because they're positively charged ions. Positively charged hydrogens always follow negatively charged electrons. So think of electrons as little high school girls. They're real cute. And the hydrogen ions are their high school boyfriends. And they're going to follow them everywhere. What else do we get out? 2 pyruvates. And you will also get out 2 ATP. Now that's a net gain. You invest 2, you get 4 by the end. I don't care if you remember all of that. Just know when you break that bond, your net gain for that first step is 2 ATP. Right? Aerobic cellular respiration. Glycolysis is an anaerobic reaction. There's no oxygen required. That's an anaerobic step. Your first step of aerobic cellular respiration is actually anaerobic. So you don't need oxygen for the first step. This splitting of a compound is the hydrolysis, sort of. And you get electrons and hydrogens released. It's an oxidation. Oxidation is burning. So what are you doing? You're burning your glucose.
You're losing electrons.
Yep. Oxidation is loss of electrons. Or you could say Leo. Loss of electrons is oxidation. Or you could say oil. Oil is loss. When you lose electrons and hydrogens, you're actually losing energy. So this molecule has lost energy when that bond broke. Now the energy is released. What do I want to do with that free energy? I want to make ATP out of it. I want to use that energy to make that phosphate bond to attach an extra phosphate to my ADP. Now I have ATP. So that's the whole object. You break each bond in your glucose. Each time you get electrons and hydrogens, that's the energy that was in those bonds. You're going to recapture that energy and use it to make phosphate bonds, making your ADP back to ATP. So now you have ATP, you can break the bond and use that energy to make proteins or replicate your DNA. So, in aerobic cellular respiration, your first step is glycolysis. If this were a bacterial cell or a eukaryotic cell, this process is going to happen in the cytoplasm of the cell. Alrighty. Now, we got to go to step 2. Step 2 is called the Krebs cycle. So, I wish that was up higher, but it's not, so I'll just let's do it this way. These pyruvates, we got to go to step 2. Step 2 actually starts here. This is a transition step. All right. What popped into my head and it just popped out? What was it? Oh my gosh. All right. What happened in glycolysis? This is an incomplete burning, or an incomplete oxidation, or an incomplete combustion, whatever you want to call it, an incomplete breakdown of glucose. Why is it incomplete? I only broke one bond. There's energy in the rest of those bonds, and if oxygen is available, I can break the rest of the bonds and get the energy out of it. So for step 2, O2 is required. And step 2 is called Krebs citric acid cycle. I'll explain why in a minute. old that I remember when this was a big deal. And they're like, oh, Dr. Krebs is so cool, Krebs citric acid. I'm like, oh God, whatever. Anyway, okay, so after glycolysis, what do you have left? 2 pyruvates. If you want to break the bonds to complete your combustion of glucose, you're going to have oxygen required, oxygen available. Krebs citric acid cycle, the purpose is to complete the combustion or complete the breakdown of the glucose. So you're going to complete the breakdown. But you're not breaking down glucose anymore, it's actually the pyruvates that you're breaking down, right? Complete the breakdown of all the bonds. Okay, so I'm going to just move over here. Sorry, so I have more board space. Okay, this transition step. Oh good, Colt is here. Get up here and do this. I'm so over it. Okay, what is this? This is my pyruvate, right? So 1 pyruvate at a time is going to enter the Krebs cycle. And this is actually not step 2, this is the transition step. So in this transition step, I always tell analogies for everything. You must think I'm freaking nuts. When I was a kid, and I was in high school, I was the first person in my family ever to go to college. And I knew I wanted to go to college, because I sure as hell was not going to live my mother's life. She was trapped with awful husbands and too many freaking babies. I need a college education so I can get a job, earn my own money, and have my own house and my own cat. Because I'm not living my life like her. So, bless her heart, poor thing,